Hello, everyone. I am excited to have a very special join us today. Special guest join us today. Joining us is Dr. Sriram Mohan from Rose-Hulman Institute of Technology. It's a pleasure to have you with us, Dr. Mohan. Thank you for agreeing to do this session with us.
I'm excited to be a part of this podcast, and I look forward to working with some of the brilliant students you provide scholarships for.
Fantastic. So let me introduce Dr. Mohan to you. Dr. Mohan received engineering degree in computer science and engineering from University of Madras, and then a MS and a PhD degrees in computer science from Indiana University. During his time
Mhm.
at Rose-Hulman, Dr. Sriram has served as a consultant in Hadoop and NoSQL systems and has helped a variety of clients in media, insurance, and telecommunication sectors. In addition to his industrial consultation activities, he also maintains an active research profile in data science and education research that has led to over 30 publications and presentations. At Rose, he has focused on incorporating reflection and problem based learning activities in the software engineering curriculum. He has been fundamental to the revamp of the entire software engineering program at Rose-Hulman. He is the founding member of the engineering design program and continues to serve on the leadership team that has developed innovative ways to integrate humanities, science, math, and engineering curricula into a studio based education model. And we would love to learn a little more on that.
Hmm.
In
Hmm.
2015, he was selected for the Outstanding Young Alumni Award by the School of Informatics and Computing at Indiana University. He also serves as a facilitator for MACH, which is Making Academic Change Happen, which is a unique faculty development experience aimed at helping faculty and administrators develop a change develop a change agent toolbox. It's
Hmm.
such a pleasure to have you with us today. Thank you so much. And we'll straight away jump into the questions. But before
Hmm.
we go into that, I'd love to learn a little more about you and a little more about your journey from Chennai, Madras to Indiana University, and now to
Uh-huh.
leading computer science program and building the engineering design program at Rose-Hulman.
Sure. Thank you for having me. I look forward to this conversation. My name is Sriram. I was born, brought up in Chennai, and I did my high school education, elementary, all of those in schools in Chennai, and then finished my undergraduate degree. It was a bachelor's of engineering degree, focusing on computer science. I was pretty young when I finished my undergraduate degree, and I had a job offer, but I wasn't sure what I wanted to do with my own career. And my family has been very high on education, and they said, I, I was 20. I was 20 when I finished my undergrad
Yeah.
degree, and there is plenty of time to work. It's time to know, it's time to study, and it's time to learn more. I've always been interested in working with data. So I decided to apply for schools with data, with an emphasis on data, and Indiana University happened to be one of those schools. I initially came to Indiana University to pursue a master's degree. But by the end of my first year of my master's degree, with a lot of encouragement from my faculty, they said, you have the ability and the potential. You should not stop at a master's degree. They encouraged me to apply for the PhD program. I did. I spent my PhD at Indiana University working on securing XML, and now I would say document-based database, document-oriented database systems. And if you had asked me at any point during my undergraduate degree or even my graduate school, would I end up as an academic? The answer would have been no. My parents would have openly laughed. They still don't understand how I ended up in academia, but I got an opportunity to teach. And while I was at IU, as Indiana University, commonly referred to as IU, to teach a class. They gave me complete control over the class, so I ended up teaching the class. And I found that experience to be thrilling. Like the idea of preparing material, slides, encouraging students, and inviting them into this field that I found particularly fascinating it was almost like being on a stage, acting and performing. And I really, really liked that. So when the time came for what I was going to do as I was wrapping up my PhD, I decided I wanted to teach first. So I focused on academic institutions where teaching was prized. So in Rose-Hulman, I had some friends who had graduated from Rose-Hulman, and it has a sterling reputation within the U.S. and the tech sector. I believe at this point we have ranked. Santana is probably going to kill me here. I think it's 26 years as the nation's best undergraduate institution. So
Yeah, yeah,
I I wanted that opportunity to teach. I interviewed. I love the students. What we have are really, really smart students who want to learn,
yeah.
who don't mind being pushed. And so that's how I ended up in teaching. I enjoyed what I was doing. And during my time at Rose, computer science has changed a lot. The world of data has changed a lot.
Yeah.
And that ability to continuously innovate to figure out what should be taught, what's the best way to teach. And that's sort of what I do. Every few years, it looks like computer science becomes something else. And it allows me to grow. It allows me to get my students along. So that's sort of how I ended up. And then along the way, I learned a lot about how to introduce new programs, how to change new programs. And that's the service now we offer other faculty and other institutions. You want to do something, how do you go about doing it? So that's
And
me. That's me in a nutshell. And we'll
yes.
go from here.
Wow, fantastic. Thanks for sharing that. And you say that computer science changes every few years, right? And now we're talking
Mm-hmm.
about AI, and it's
Mm-hmm.
the rise of AI. So how is computer science fundamentally changing with the rise of AI, and how do you see it changing in the next few years?
So computer science as a field, I was just thinking about it as I was getting ready this morning in preparation, or rather evening for all of you folks in India. Uh, Computer science, as I said, changes a lot. It's a field that's less than 100 years old, right? When I studied computer science, we didn't even have Google. It was a world before Google when I was an undergrad in computer science. If you had a question, you went to a book and you read the book. You then tried to adapt whatever you learned from that book to the situation, to the problem you're facing. I think what Google did in 2000, in the early 2000s, with PageRank and all the wonderful search engine tools that have come into, is make it easier for people to access information. And the thing you had to worry about at that point of time was, is the information that Google is providing, the page it's directing me to, is it a trustworthy page? Is this enough? Is this accurate information that I can take, adapt? And what I feel about AI is it's taking that next step. Why do you have to go to that page? Here is this wonderful tool that has the ability to absorb information and provide it in a manner. I'm talking about generative AI here, and provide it in a manner that makes it easy for people to access information. Again, the question of verifying the information you obtain from these tools is there, but AI, the way it makes people access information that much better. And the other thing I think is it allows us to solve problems that people didn't think were solvable even a decade ago. If you had asked me 25 years ago, you could have a software system that would be even able to take a look at an image and identify who the person is, that wasn't a thing 25 years ago. But now, even within the 10 years ago, yeah, I can do that. And now it has the, so its tools keep evolving, but at the end of the day, computer science is about solving problems and making people's lives easier. To me, AI is a toolkit there. It's a toolkit that allows me to do it. And it means what passes off as a basic skill set for a new software engineer or a professional is changing. But that's always the field. The field will always be changing. The one thing I always tell my own students is don't expect that I'm going to be able to teach you everything you need to know in within 4 years or irrespective of the amount of time you spend. What I will teach you is how to learn. I will give you a variety of experiences and a variety of ways in which you're solving problems for people, projects, real world projects. That means when you go to industry or when you go to grad school, you are this is not new for you. This is a situation you faced. And to me, I think that's important to learn how to learn and to be always ready to learn. This field in my lifetime and the listener's lifetime, it's going to change and reinvent itself, I would say, at least once a decade. You need to be willing to adapt to it.
Absolutely. And you said learn how to learn. I think that's a very,
Mm-hmm,
very important skill, and
mm-hmm,
it's critical in fields which evolve so fast. I mean, there are some fields
mm-hmm,
that probably change, but not as fast as a field of
mm-hmm,
technology and computer science.
mm-hmm,
Now,
mm-hmm.
when students are looking at computer science as a major, what core skills do today's computer science students need to develop to stay relevant in an AI-driven world?
So I, I think problem solving problem solving, it continues to be important because at the end of the day we are here to solve problems that other organizations or companies face. So we produce products because it helps make somebody's life easier in some way or another. So problem solving is important. uh, Being willing to learn, we've talked about this again, that's going to be important. But to me, I think as AI becomes better and better at maybe helping developers write code a little better, it's about how you integrate systems together. That's going to become an important thing. Yes, I could use Claude Code or Crusoe to help me generate, or Cursor to help me generate a little bit of the code that I'm using towards solving a bigger problem. But what I'm trying to do is when you're developing a prototype, that's one thing. One person is using it. But when you want a system that is going to be used by millions of people, you have to engineer systems together. How do you do that in an effective manner? That's going to be a very, very important skill. But I think to me, the most important thing is being able to work with people. If to get AI to help you do something, you need to first understand what is the underlying need behind the problem. I think that is going to become important. And then debugging is going to become more and more important because you work with AI. Let's say I think of it as working with a team of software engineers and a team of AI agents to solve problems. And you're working with the code base, but there are going to be bugs. How do you debug it? And how do you provide it, adapt it into a product that a person can use? I think that the people skills and debugging are going to become even more important the world of AI going
Yeah,
forward.
yeah, absolutely. Problem solving, learning to learn, uh,
Mm-hmm,
and working in collaboration with people, and merging or sort of integrating systems. And I think
mm-hmm,
bringing together
mm-hmm,
different components. It could be, let's
mm-hmm,
say, mechanical components working in conjunction with code, or it
mm-hmm.
could be a completely different system. Let's say a system of psychologists of some sort
Yep. Mm-hmm,
working in the back end, working, using a code of
mm-hmm,
some sort to find
mm-hmm,
solutions for
mm-hmm,
problems
mm-hmm.
in that field. So completely wide range of things. I think that's fantastic. That's a fantastic way to put that you should be able to bring systems together in some way while
Mm-hmm.
also being able to interact with other human beings, right? I
Yes,
mean,
communication is going to
yeah,
be important. If you, I mean, what I always tell my students is it's great that you are technically brilliant, but if you can't get others to understand what it is that you're talking about or how it is that you can help them, what's the
yeah,
point?
yes, it doesn't help anyone. Yeah, yeah.
Mm-hmm,
Okay, so let's talk a little bit about Rose-Hulman and
mm-hmm.
how you are adopting your how you are adapting your computer science curriculum to reflect uh, the growing influence of AI.
So we are doing a so what Rose-Hulman has always prided ourselves on is we want students to be after 4 years here, we want them to be ready for whatever the world might throw at them. So the way I think about it is we want students who are excellent in a system where AI can be used and also in setups where AI cannot be used, right? So we want students who are very, very well grounded in the fundamentals. We want them to understand how to do things. We want them to develop practical skills. I cannot think of outside of the math-based classes that we expect our students to take, where students are not expected to do projects. Everything is about, yes, I know what this is. I can teach you what this is, but do you know what it is and do you know how to use it? So that is sort of that's always been a core part of how Rose-Hulman does things. We want hands-on skills development is something we pride ourselves on from day one to the end of 4 years. So some of the things we are doing is early on, we are not really for, like, let's say you're learning CS1 or CS2, learning how to program. We still want you to be able to do the things. So we may not let you use AI in those areas. But as you slowly mature through the curriculum, what we have sort of started doing is in any given class, we will teach you the fundamentals of the class. But then at the end of the day, you're taking the fundamentals and applying it somewhere. When you're beginning to apply it, let's use AI there. So I'll give you a couple of examples. We have required sophomore level classes on web development and quality assurance. So when students are taking a class on web development, a lot of universities like, oh, we will teach you this framework or that framework. There are dime a dozen frameworks, and these frameworks keep changing. So what the approach we take is, rather than teaching you a specific framework, we'll teach you how these frameworks work. Let's build one of these from scratch. So you actually understand how the nuts and bolts fit together. And so while we do that, students don't use AI. They actually sit and build these things. But when it comes time for a final project, and we always do team-based final projects in our classes, what we say is, well, you are now allowed to use AI. Show me that you understand how these nuts and bolts components work together by learning a framework, use AI, and develop something you're passionate about. So the students know the basics, but they're also gaining that experience of learning something new on their own, working with AI. And that's a skill that only comes with experience. And this is a second-year student doing it in a team. Similarly, a couple of quarters later, we do something similar with a course on software quality assurance. What we are teaching them is, at the end of the day, you need to be able to validate that the software you built does what it's supposed to do and only that. So students write a lot of test cases. We follow a philosophy called test first development. So you write the test first, and then you write the code that passes the test case. So the students, when they write the test cases, they write it on their own. But the code that you have to generate to pass the test cases, let's use AI for that. So for each class, we identify what is that critical skill you need to know. So even in a world without AI, you can still do it. But then let's apply it with help of AI. And that's a philosophy we've seen work really well for us. And the one other thing I'll say in general is we've always been nimble. We understand the field changes. And to make sure that we are where we're supposed to be, we have two big things that happen. We have an industry board of advisors. These are people who are some of whom are just starting their careers, some of whom are like mid-level seniority, and some of whom they are CEOs and CTOs of companies. We work with them on a yearly basis to try and predict where is industry marching towards, where are the grad schools going towards. So they help us analyze our curriculum to identify areas of opportunities for growth. And then we also have, I would say, on any given, about, let's say, a quarter of our faculty work in industry during the summer. trying to see what is going on. We have a lot of our faculty doing research. We also have a quarter of our faculty who are actively engaged in industry during summer months. The idea for us always has been, let's be aware of what the upcoming trends are, and let's start introducing curriculum before it becomes a thing. I know machine learning, deep reinforcement learning are becoming very important these days, but we've been teaching them for about 7 years now. We've had courses in these areas because we've realized that this is where things are going. Let's go ahead and introduce classes, and let's give students the opportunity to learn. Let's give students the opportunity to work on projects. So when they go out, it's not like, oh, you want me to do that? Yeah, I've done that before. Or I've done something like that before, and makes it easier for them to adapt.
Well, it's always we always hear that academia run 5 years behind the industry, but
Mm-hmm.
I don't think that's true in your case. I mean, you are just walking hands in hand with the industry, and I mean, you're just mentioning some of these tools. You are just some of these technologies. You are just while they might not be
Mm-hmm.
so prevalent in the industry, you've already started teaching your students that,
Mm-hmm.
and I think that's fantastic. That along with this this very unique approach of first designing the test cases and then sort of going backwards towards
Mm-hmm.
towards building that product, towards writing that code. I
Mm-hmm.
think that's very unique. I mean, I myself, I come from a software background. I did work in a software
Okay.
company for some time,
Mm-hmm.
actually a
Mm-hmm.
Chennai-based company called Polaris. So, and
I'm aware of them. Yeah.
yeah, and I mean, we are always taught you write the code and then a different set of people will be testers and
Uh-huh.
they'll
Mm-hmm.
test it there
Mm-hmm.
using
Mm-hmm.
their own methods or their own
Mm-hmm.
systems, which
Mm-hmm.
which usually would mean that there is a disconnect sometimes. But when
Yep.
you
Mm-hmm.
are the one who is writing the test cases and now you're moving backwards and sort of designing that tool to ensure that all these
Mm-hmm.
test
Mm-hmm.
cases are taken care of. I think that's a fantastic approach. It's amazing. Yeah.
Thank you. We always felt like we need to experiment with curriculum because there's always better ways to do things. And you can just walk down the hallway to a faculty member's office, and there's always think, what can I do better? How can I
Yeah.
make this
Yeah.
class better?
Yeah. Yeah.
So.
Wow, superb. So let's talk a little bit about students' projects. You shared a little bit
Mm-hmm.
already about what kind of hands-on.
Mm-hmm.
I mean, your curriculum is completely hands-on. Apart
Mm-hmm.
from that math course,
Math-based classes. Yeah.
yeah,
Mm-hmm.
everything else requires students to
Mm-hmm.
build projects.
Mm-hmm.
So take us through some of those projects and research, and where have they used, let's say, AI or machine learning or some of those new age technologies, and yeah, yeah,
Sure. I can talk about uh, early on in our CS1, effectively, the kind of work we end up having students do is we use Python. So students do a lot of data analysis projects. They identify a data set, and we ask them to do some interesting data analysis and do some visualizations. So just get their hands dirty. As they move through the curriculum, either students sometimes CS2, they sometimes build games, or they identify a little area of research and say, okay, we taught you how to do object-oriented design in this class. Pick a small area for research, do the research, develop something, but I want you to apply the concepts you've learned in class. As they go through the curriculum, depending upon what the class is, the type of project changes. But since you asked for machine learning, AI related projects, there's a class that I've been sitting in on just because I may teach it in the next few years. Just see what it's a class on data mining. And what the entire project experience has been, it's about helping people make decisions. So students identify a data set, they curate the data set, they do the analysis, they do the machine learning, and then say the final idea is you need to convince somebody who needs to make a decision based on the data that this is what, because that's the whole point, right? All the
Yeah.
fancy machine learning, it's about helping people make decisions. So let's actually have you do that. We offered our first class on generative AI about in 2022, I believe, just after the first version of ChatGPT that then became that was sort of and so one of the tools that I find very useful today is we have a fairly large catalog, and it's kind of hard of courses that students can take. So students sometimes are, okay, I want to take this class that is offered by this department.
Yeah.
When is it offered? Yes, we have a website, we have flowcharts, but what we have also is a custom built chatbot built by
Mhm.
students that
Yeah.
you can go ask it the question. It's been trained on our own data set and it can answer. Oh, you want to take a class on data mining? You want to take the class on data mining? You need to be able to, you should have finished this and this, and it's offered in the fall and winter quarter or something along those lines. So
Yeah.
that's an example of a project. This is a class project. This is not something, this is just what, that's what I mean when I say
Yeah.
we
Yeah.
teach them the skills and we want to apply,
Yeah.
we ask them to build actual tools that
Yeah.
people are using. Other examples, you also mentioned research. We have in the area of AI, we have faculty with expertise in computer vision, natural language processing, machine learning, deep learning, general AI. We have had freshman students get involved with. I'll just give you an example of a student without mentioning the student's name. He walked into my office first week, say, "Hey, I'm interested in doing research." So I connected him with a faculty member, and by the end of his first year, that student had a actual publication co-authored with a faculty member, and then at the end of his sophomore year, we connected him with a research experience opportunity for undergraduates, and he has already published, I believe, 5 papers, and there are 3 other
Wow.
papers. So if we have a student who's interested in doing something, we can
Yeah.
connect them with the right people and make sure that they have the experience. We are a small school built around interactions with students. So what we value is, okay, we have a student who's interested in X and Y. What can we do to help that student follow their passion, follow their dream? So that's an example. The other thing we also have is we have an entity that works. It's part of Rose-Hulman called Rose-Hulman Ventures. It's part of a new innovation grow. And the idea here always has been companies and organizations and other universities have projects and ideas that they want to see come to fruition. And they may
Mm.
not either have the manpower, they may not have the skill set, but we have the engineering and computer science and mathematics skill set here.
Wow.
So companies say, here are products that we want built innovative, innovative ones. And we find a team of Rose-Hulman students that work under the guidance of professional software engineers and professional engineers while they are in school. They can work during the school year or also as an internship during the summer, and they are contributing to actual products. It's not like you have to be a senior.
Yeah.
Freshmen, sophomores, juniors, anybody can join one of these teams. You need to apply, you get picked, and you work on these projects. And
Mm.
that's something unique about us because
Yeah.
you're maybe a freshman or a sophomore contributing to a product while you're in school that is actually impacting people's lives. So examples of where we've used AI, we worked for a big manufacturing firm, will say that, and they wanted to do precision planting of crops. Like, what is the ideal distance between seeds so that it has maximum exposure to sunlight and can access nutrients? Behind the scenes, it's machine learning. That's an example of something we've done. So
Yeah.
there is there are some projects I cannot really talk about, but I can also talk
Yeah.
about for the next 2 hours here. But the idea always has been it's about solving problems for
Yeah.
people
Yeah.
while you're here as a
Yeah.
student.
Fantastic. Thanks for sharing those really practical ideas. And And I can imagine the kind of exposure that students are getting, and they are actually getting work experience while they are
Hmm.
still
Hmm.
at college. Now,
Yes.
with all these resources, and even with access to
Hmm.
all kind of AI tools, uh, how do you balance teaching and ensure that students are not using AI everywhere? And how are you as how are the professors one step ahead of the students all the time? And I hope not all your students end up watching this podcast. But if there is
No.
some uh, sort of interesting uh, ways in which you ensure that students are learning and not just passing everything on to AI, let's say. And
The, it all revolves around the idea of a culture, right? At the end of the day, culture of integrity. We value things, and we want to pass on those values to our students. Right from day one, students are told in a variety of ways. There are places where you're going to be allowed to use it. There are places where you're not going to be allowed to use it because we still want you to master
yeah,
some skills. And one of the things that I actually admire about a lot of students is they get that. They do understand that if I don't pick up the skills, what is it that what value am I taking
yeah,
to an organization?
yeah,
Right. So they realize it very quickly that AI is a tool, and AI is not meant to replace my own thinking.
mm,
And the analogy I've often used, and I know other colleagues have often used, is kind of like going to a gym and saying, I want to go to the gym. I will ask my friend to go to the gym. I'll ask my friend to go bowl 10 overs every day, but I expect to be the opening bowler for my favorite IPL team.
yeah, yeah,
Right? That's
yeah,
not how it works. If you want to be something, you have to put in that sweat
yeah,
equity. You have to be willing to invest that time. And I think that analogy goes well with our students, because they realize at the end of the day, I can use AI to make myself better, but AI is not going to replace the value I bring.
yeah, yeah.
So that's, I mean, it's one of those things where you have to keep working with the students,
Mm,
and they do see it, and we have what we call the student advisory board. I meet with them once a term. It's made up of three students
mm.
from every year,
Okay.
and it's a way for students to tell us what's going on. And
Mm.
sometimes they tell us, like, you are doing too much here. Put a let's not do this, because I don't want them. We still want to be able to learn how to do this or that or that. So it's that balance in, we listen to our students, they listen to us, we build relationships, and then we value and we leverage those relationships to take students where they need to go.
Yeah.
The, these are to give you an example of one of the things in my last meeting with it was a third year student. um, uh, uh, Her parents are from India, but she was born brought up here. She mentioned something to me. At the end of the day, we also want students to be able to learn from other humans, right? Because when I go to industry, if I have a problem with something that I'm working on, it's not ChatGPT or Claude that's going to help me. I have to go talk about this particular design with my fellow engineer. And I that is I think that's a lesson our students are beginning to understand. Yes, time pressure. Sometimes they want to take the shortcut, but they realize taking the shortcut has consequences, and the consequences are impacting them in the long term. And once they get that, it's easy to work with them.
Yeah, yeah, yeah. Absolutely. Wow, fantastic. And many 17-year-olds are going to be watching this podcast. So thanks for
Mm-hmm.
sharing all that wonderful advice. But what is that one advice that you would like to give to these high school students who are considering computer science as a major, uh, computer science or some variation of computer science, let's say, as a major,
Mm-hmm.
uh,
Mm-hmm.
in this
So
very
computer
fast
science,
changing world?
AI,
Yeah.
cybersecurity. But I think the constant thing I would say is be curious. Be curious. If there's only one thing I can say, I would say be curious. If I can say one more, I would say it is okay to ask for help. If you don't know something, go ask somebody to teach it to you. And I think
Yeah.
as long as you're willing to do those, it doesn't matter what your choice of field is, you will
Yeah.
continue to grow, you will continue to shine. Hard work, yeah, sure, that's necessary.
Yeah.
Work ethic, curiosity, and being willing to ask for help. And I'll throw in one more, humility.
Yeah. Yeah. Absolutely. Fantastic. Curiosity, uh, humility, and then ask for help. The help
Yeah,
is available. Yeah, yeah, yeah. Wow,
yeah.
fantastic. Thank you so much, Dr. Mohan. This was such a fantastic and enlightening conversation. I really enjoyed learning about how Rose is, about Rose's curriculum and the interesting project-based learning
Mm-hmm.
that you follow at Rose. Thank you so much for your time on this podcast today.
Okay, thank you for having me. And to the listeners, if you have a question, feel free to send me an email. I'm sure it will be there as a part of the podcast somewhere. Please feel to send me an email. Looking forward to talking to you all.
Fantastic. Thank you so much.